Yeah. Okay.
Here, we got to talk about a couple of things. First of all, do you know what this is? You're studying conic sections right now, I assume?
Yeah.
Because we're looking at some circles and some ellipses.
Yeah, I've heard those before.
What is this?
What is what?
What is that shape?
An ellipse? Isn't it like a crescent, kind of?
It's a circle.
Oh, okay.
An ellipse is this format. Okay?
Okay.
Here's the format. Again, I cannot stress how important it is to understand the general format of these equations. You just can't go right without it, and you're going to go wrong without it. So you got to know it. You got to start with that.
Okay.
What's H and K?
H and K.
Mm-hmm.
Is H 2?
Well, that's the center of the circle. First of all, we're looking at a circle because it doesn't have denominators like this one does down on number 3. Okay? So we're looking at a circle. The only important thing on a circle is its center and its radius, right? In other words, if I know where the center is and I know what the radius is, then I can draw it. Well, its center is H comma K. In this case, what is that?
H comma K.
Yeah, what point is the center of this circle? That's where you're always going to start. When you're drawing a circle, when you're graphing,
9.
you got to find its center.
Okay. What would it be? Because like I don't know much about these equations, to be honest. This is the first time I've seen them.
Remember H and K. H is the x coordinate of the center. K is the y coordinate of the center.
Okay.
So I'm looking at x minus 2. So what is H?
Is it negative 2?
No, it's positive 2.
No, positive 2? Okay.
In other words, H, since I'm looking at H minus 2, then H has to be that number right there, which is a positive 2. Now what's K?
Okay.
K is the y coordinate.
K would be, would K be positive, or yeah, negative 4? Or positive 4?
Negative 4. If K were positive 4, this would have to read y minus 4. The fact that it reads y plus 4 means K has to be negative 4. So if I graph this, I go to 2, negative 4. There's my center at positive 2, negative 4. What's my radius of this circle?
9 or negative 9.
The general format, everything is equal to the radius squared. Well, this is equal to 9. So tell me what the radius is.
So it'd be 81 then?
It's the square root of 9, not 9 squared.
No.
In other words, 9 is r squared. I can write this equation. 9 equals r squared. So r is 3.
Right. Okay.
And if I draw the circle about that with a radius of 3, notice that I didn't go all the way up to the x-axis because the center is at minus 4 on the y-axis. So I know it doesn't go all the way up and touch the x-axis. So that's how you do it. You have to start with the general formula and know what HK and R are, what they mean.
Okay.
Okay? All right. Let's look at the next one.
Let me write that one. Never mind. I was going to write that one down.
Well, here,
or I can look over it later.
I'm going to write it again because we need it for the next problem also. Here,
yeah, okay.
Well, I'm going to write it in the general format. The h's go with the x's, the k's go with the y's. And both terms are squared. In fact, everything's squared. Radius is squared too.
Okay.
All right. So the next one gives us a polynomial. Instead of, they don't give it to us in this format. And a lot of times they won't. They won't give it to you in the perfect format. They'll just give you a polynomial, and you have to take this format and convert it to this format. And the way you do it is by completing the square.
Okay.
And the way you complete the square is you combine the x terms, you combine the y terms, and you leave the number on the other side. And then you just complete the square on each one of them and adjust. So here's what I'm talking about. I'm going to combine the x terms, I'm going to put parentheses around it, and I'm going to leave a little room here because I'm going to complete the square by adding a number into there. With me?
Yeah, I kind of remember this. So,
and I do the same thing with the y terms. And I leave some room. And it's still equal to 7. Okay? So the point is I haven't changed it. Notice that what I have written is exactly what I'm started with. So all I've done is put some parentheses around it, separated, kept my x terms together, keep my y terms together. But the most important thing is I haven't changed anything. Always. Never change it from line to line whenever you're completing the square. That's the most important thing to do, is to make sure you have not changed anything. Now, complete the square inside the x terms. How do I complete the square?
You take half of the middle term and square it.
Okay, what do you get?
So we take negative 4, which is it 2 or negative 2? It'd be negative 2, wouldn't it? Yeah, never mind, just kidding.
Because you're going to square it anyway.
Yeah, so we just take 2, and then we square it, which is just 4.
Okay, so when I write 4 in there, I got to balance it out on the other side. I just added 4 to the left side of this equation.
Now you got to add it to the right side.
Now let's do the same thing in the y terms. Complete.
So it'd be...
When you complete the square, you're always adding it. Because even if it's a negative number, when you square it, it's always positive.
It'd be plus 9.
Okay. And I've got to add 9 to the other side also. Now, because I completed the square, I can write this in this format. I can write it as x minus 2 quantity squared. Always. You can always do that after you've completed the square. That's the reason you complete the square, so that you can write it as a linear term squared. How am I going to write the y term?
Would it be y minus 3 squared?
Add those three numbers together, 7, 4, and 9, and you get 20.
20.
There's my equation for that circle. Now, graph it. Where would I start?
Oh, we don't need to graph it on that one.
Oh, you don't? Okay.
No, we just have to find the center and the radius.
Okay, what's the center?
The center is positive 2 and positive 3.
Okay, good.
And the radius is 20.
Square root of 20.
Square root of 20, you're right, sorry.
On that other side is r squared. So you always have to take the square root of that. And
So the square root of 20?
20 is 2 root 5. So I don't know where that goes. We'll just draw a circle like that. I know you don't have to graph it, but the radius is 2 root 5.
2 root 5? Okay.
Not square root of 20 because that can be simplified.
Okay.
Okay, you always should simplify this. That's the square root of 4 times square root of 5, which is 2 root 5. So that's the radius.
Sounds good.
Okay.
All right.
Number 3. What kind of figure is this?
That's a ellipse.
And what is the standard format for an ellipse? Again, you've got to start with these general equations.
Yeah. I don't know that one off the top of my head.
Well, it's quite similar to a circle.
Okay.
I had to give you this one to start with.
Yeah, probably.
Well, there's a reason why I said that. This is the typical general format for an ellipse. But this is only the general format for an ellipse if it's a horizontal ellipse. Like that. If it's a vertical ellipse, then it's pretty close to the same thing, only the A and the B switch places. And I'll give you a little. And notice that it's always equal to 1. Okay? That is an ellipse like that. And what matters is when I'm looking at an ellipse, that's A. That's B. Okay?
Okay.
So the way to think about this is that with a horizontal ellipse, the A goes with the X term because it's along the X-axis. With a vertical ellipse, that is A. A is always the bigger term, no matter how the ellipse is oriented. But in this one down here, the A is along the y-axis, so it goes under the y term.
Okay.
So there's two general formulas for the ellipse, and they're easy to remember in the sense that the A goes with the long side of the ellipse. So
the A goes to the long side?
Yeah, my bigger denominator is how this thing is oriented. Well, let's look at this first one.
Okay.
Which has the bigger denominator? Is it under the X term or the Y term?
The Y term, or X, sorry.
No,
I just
right.
misread that.
25 is under the Y term.
Okay.
Now, remember that we're taking the square root of these numbers, but doesn't matter. The square root of 16 is 4, square root of 25 is 5. 5 is still bigger than 4. So you don't have to take the square root to figure out which one's bigger. I can see that that's the bigger denominator. That's A squared. Remember, A is always bigger than B. So if they give you a denominator under the Y term that's bigger than the denominator under the X term, then the denominator under the Y term is A squared. In other words, we're looking at that formula, not the top one.
Okay.
Okay, so I'm going to erase the top one for a moment. So this is our formula. This thing's almost in it. This format already. In other words, they didn't make us do much work here. But we need to list everything. Tell me what H is, tell me what K is, tell me what A is, and tell me what B is. Those are our unknowns.
Okay. H is 1. And K is -3. A is 25.
Square root of 25.
Yeah, square root of 25.
So in that general format, it's a squared under that y term.
Okay.
What is b?
B is the square root of 16.
Which is 4. Okay.
Okay.
Now, if I wanted to graph that, it would be relatively simple. First of all, we've got their center. We got to keep going here. When you are dealing with ellipses, there's 2 points in that ellipse that are particularly of importance. One is a focus about there. The other is a focus about there.
Okay.
Every ellipse is going to have 2 foci. A circle doesn't have foci. A circle, the only important point is its center and its radius. But an ellipse is different. These 2 foci have tremendous significance in terms of their reflective values. If I fire a tennis ball from that foci, automatically goes to the other foci no matter where I fire it. I can fire that tennis ball at that point and it goes to that foci. I can fire it at that point and it goes to that foci. In other words, anytime you send an object from one foci and bounce it off the ellipse, let's say you had an elliptical skating ring and these truly were tennis balls. You just shoot that tennis ball, no matter where you aimed it, it would go to the other foci.
True.
In the Capitol building, it's the shape of an ellipse. And anybody talking from this point right here, all of the sound waves bounce off all sides of the ellipse and go to the other focus. So you could sit in this chamber in a chair right there, and if somebody else was right there, you could whisper and they could hear you, even though they might be 100 feet away. So the properties of an ellipse are extremely important. They're kind of like the reflective properties of a parabola. That's what's important about these objects as conic sections, is their reflective properties. Okay, now let's talk about where those foci are. Let me redraw this. If I have a vertical ellipse, here's how I dimension it. That is A. That is C.
All right.
And C is related to A by C squared equals A squared minus B squared. That's just the standard way that the focal length is related to these major and minor radiuses. So let's plug it in. C squared equals 25 minus 16. C squared equals 9. C equals 3. That means that distance is 3 feet from the center up. And there's a second one that's also 3 feet from the center down. There's the center. There's one foci, there's the other. So the focal distance is 3.
The focal distance?
That's what they're asking for, the focal distance. And what that means is the distance from the center of the ellipse to the focus, to either focus, is 3 feet.
Okay.
Okay? And that's what that is. As complicated as that looks, that's my c squared equals a squared plus b squared.
All right.
Or, excuse me,
so the
squared minus b squared. I don't like the fact that she put absolute values around that. The reason I don't like it is because they're not needed. A is always bigger than b. So a squared minus b squared is always a positive number.
Okay.
Okay.
So the focal distance is 3.
So C, what she's calling f of whatever, j, the focal length, is equal to the square root of a squared minus b squared. That's how you get the focal length.
Okay.
2 focal points and then graph. Okay, well, we've got the equation of this thing. Let me draw it. In other words, you start with the equation. Whoops. Actually, you start with everything we've already figured out. Let's add c to that. C is equal to 3. Okay? So, to graph it, start with the center. Where's the center?
3. No, that's the focal distance. Just kidding.
Center is what?
No, the center is 3.
No, it isn't.
3. No, it isn't. Okay.
Look at the equation.
Wait, the center is 1 and -3.
Perfect. 1, -3 is right there. Okay? So that's the center. We'll put a little designation there. We also know, I'm going to approximate the shape because I don't know whether it goes over that y-axis or not, but I'm going to draw a reasonable ellipse that is vertical. Remember, I know it's vertical because I can tell by the numbers that the biggest number is under the y-axis. Furthermore, that center is 1, -3. And if the focal length is 3, what are the coordinates of those 2 points?
How far up does it go above it again?
C is 3.
Okay. So, would you go 3 points up from that directly?
So 1, 0 is where the first focus is, the top one. What's the bottom?
It'd be 1, -6.
Yeah. Now, usually on problems regarding ellipses, they want all 7 points. Well, we just figured 3 points. The other 3 that they really want are the major vertices and the minor vertices. So tell me what this point up here is.
Oops.
A is 5.
A is 5, so does it go up 5 then? Or?
Yep.
So would it just be 1, 5?
No, it's 5 from the center.
2.
You gotta measure
okay, my bad.
Just like you had to measure up 3 from the center to find the focus. And go down 5 so that this point is what?
It'd be 1, -11.
-8. Down 5.
I keep forgetting it's from the center.
Okay. And now this minor vertex. The major vertex is the vertex that lies along the longest axis. The minor vertex is the small axis. Well, what's B?
What's B?
Uh-huh.
B is 4.
Okay, so we're
So
4 points to the left of the center. Where does that put us?
to the left, 2, 1. That put us at. Wait, would we still be negative at that point? No, right or no?
4 points to the left
I'm
of
reading it.
1 is -3.
Okay.
Now the only
3 minus 3.
one is this one right here. Tell me what the coordinates on that are.
Which one? Sorry, someone came in my room.
The other minor vertice. That one, right?
The other minor vertice.
Uh-huh. That's the 7th point. We've got 6 points so far. We got the 2 major vertices, we got the 3 middle points, and we got the left major or minor vertice. So what's the right one? The right one's easy. If you got the left one and you know what B is.
So it just goes over to the left 4 then, right? Or
We went
right,
to the left already. To the right 4.
I meant.
Okay, so what's the points? If the coordinate of the center is 1, comma, -3, what's 4 points to the right of that?
4 points to the right of that, so that would be -7 and +5. Or, yeah.
You're going 4 points to the right of the center.
Yeah, to the right.
Okay, well, what's 4 points to the right of 1?
That'd be 5. Am I misthinking this here or something?
Well, yeah, apparently, to get 7. 4 points
No, I
to the
said
right
it
of
was.
1 is 5. And the
That's what I
y
said.
coordinate doesn't change. We're on the same horizontal axis.
That's.
The center and the 2 minor vertices all have the same y coordinate. Just like the center, the focuses, and the major vertices all have the same x coordinate, which is 1. You with me? Now, she didn't ask these other 2 questions, but typically that's what you have to know when you're studying ellipses, is you have to know all 7 points.
Okay.
Okay? All right, let's pull up another one here. Let's see.
Honestly, I think I'm gonna stop for tonight if that's all right with you. I'm just like getting a lot of people coming in my room asking me for stuff, so
Okay.
I think we're almost halfway done. So
yeah, that's fine. That's fine.
I'll just probably use you during the week and maybe tomorrow.
That whenever is fine, Merrick.
All right, thank you.
Talk to
Bye-bye.
you later. Bye-bye.